You have to know what a function is. And you know that a function has to pass the vertical line test. X's cannot repeat. If something is a function, there is a possibility it's one-to-one. A one-to-one function passes the VLT and the HLT, which means the X's and the Y's can't repeat. So these are things you need to know to be able to do some of these multiple choice questions. The other thing that you need to know is that only one-to-one functions have inverse functions. Okay, so are there any questions on the first page?
No.
We're all good. Everyone got them right? How about the number 3, center and radius of a circle? You remember that? Number 4, I kind of talked to you about yesterday, how they gave you domain numbers and they just wanted to know the biggest range number. So they gave you the X's, you had to find the biggest Y. So you had to just plug the numbers in. For number 5 and number 6, you're just putting numbers into the function and simplifying. All right, so let's move on then. You sure? Ask now. Don't be shy. It's okay. You need to ask. Today I'll give a 10th period, but then you're kind of, on your own. Tomorrow you're taking the test. All right, number 7 is another, solving. Well, no, I'm sorry. Number 7 is composition. You go from right to left. First you put the X into the G. You get an answer. You put that answer into the F. Direct variation, inverse variation. Two different kind of variations. We studied it yesterday. We need to know these two different variations to do number 8. How do we set up a direct variation? Who remembers? All right, how about this? There are only 2 ways. It could be proportion or multiplication.
Direct variation is the proportion.
And the inverse is when you multiply. That's how you set them up. So number 8, I think, was an inverse. So you had to multiply. Number 9 was a proportion. It's a direct variation. Because as the number of beats increase, then the hour increased. So it was a direct. You had to set up a proportion. We're all good? Okay. I want to go to now number 10, number 11. Number 10 and number 11 are domain problems. Once again, I'm just reviewing all your notes to figure out domain. If you have any kind of linear function, like y equals 3x plus 2, the domain is real. There's no issue. X can be anything. But if you have a fraction, a rational expression, like, let me give you an example, where you have a 1 over x minus 3. Remember, the denominator can never be 0. So there's going to be a domain issue. If you have a radical, like the square root of 3x plus 2, and you have that as a function, and I ask you to find the domain, remember, the radicand can only be what? Greater than or equal to 0. And then if you combined and you have a radical, rational, where the radical is in the denominator, your radicand can only be greater. It can't be equal. So those are the 3 cases that we studied. Those are the things you need to know. They're in your notes. I know they are. And that's how you're going to do number 10 and 11. Any questions? So for number 10, it was greater than or equal to 0. And for number 11, it was just greater than 0. Okay. Multiple choice. Anything on that page? Anything you want me to go over? Ask now. Nothing. Number 14, I just drew a picture of a function and I just said, what was the range? Don't forget that range is wise. Tomorrow on the test I might ask you about domain. And then domain, it would be the x's. Okay? Number 15, inverse, how to find an inverse. Okay, we studied that. Let's write it into our study notes. How do I find an inverse? An inverse is a reflection through the line y equal x. How do you make it? Pull the old switcheroo. You switch the x and the y and solve for y. You only will have an inverse function if the original function is 1 to 1. Okay, so for number 15, you pull the old switcheroo. Number 16 is not a function. Y. What is that when you have an x squared and a y squared in a function? What is that called? A circle. Circles are not functions, they're relations, but you know how to find the center and the radius. Now we're on number 17 and number 18, the arithmetic of functions. This I think most students find pretty easy. Plugging numbers in, adding them, doing composition. Does anybody have any questions for 17A or B? No? C and D? Anything you're getting wrong? Yes! Finally! Thank you. Put me to work a little here. Okay, so for number 18, you're given a function, 3x squared plus 2, and you're given another function, 2x, and for 18a, you're asked to find the composition. Don't let these nested brackets scare you. This is just composition. It's just another way of writing composition. So, the way you do this is you're going to go from right to left. You're going to take the number 2 and plug it into G. So I'm going to do that first. G of 2. Put a 2 into G. I got 2 times 2 is 4. So far, so good? Then take that answer and plug it into your F function. F of 4. 3 bracket 4 squared plus 2. 3 bracket 4 squared plus 2. And then what is that? 16, 48, 50? Did I do that right? Okay, does that help you?
Yeah. I did it. I multiplied 3 and 4 and I squared 12.
Oh, you forgot the PEMDAS. Please excuse dear Aunt Sally rule. Does everyone see what she did? She forgot to do exponents before she multiplied. Very common mistake. Don't worry. How about number 20, finding the range in the domain on a step function?
Do 19. Yeah, 19A.
Oh, I forgot 19A and B. I'm sorry. Okay. Sure. And a lot of you said that, right? A lot of you had trouble with 19A and B. Let's see why. All right, so you got a function. You had to find the inverse. So did you pull the old, first let me rewrite this as a y. Okay, so now I see an x, I see a y, and I pull the old switcheroo. So it's x equals 3 minus 2y. Solve for the y. I guess I'll subtract the 3 first. So far, so good?
Yeah.
Okay, and don't forget that's a negative 2y, and then divide by negative 2. And there's your answer. Now, they just wanted you to find it?
You have like.
Oh, you don't like the way I wrote it.
Yeah, I don't
You
know
see
if
that
want
negative 2 is under the x, and that negative 2 is under the negative 3. I kind of just cleaned it up. I made it negative a half x, and then the negative 3 and the negative 2 made a positive 3x. I just rewrote it like that. Do you see what I did? The negative 2, really this was a negative, let me just show you what it was. This was a negative 2 under an x, and a negative 2 under a negative 3. And then I just cleaned it up, only because if this was multiple choice, it would be cleaned up. So I wanted you to see how to do it. Okay, I don't remember on the test which way it is, but just in case it's multiple choice. Is everyone good? 19b? 19b, you want to see that one really quickly? 19b, you're given a function. It's a parabola. But when you pull the old switcheroo, the y is now squared, which is a sideways parabola. So it's not going to be a function. Remember, an original function isn't 1 to 1. So I'm going to add 7 to both sides, take the square root, and I'm not going to get a function here. I'm going to get plus or minus the square root of x plus 7. I don't know why my pen's off. Did you get that? Everyone good? Okay. Sometimes they'll give you a restriction on the domain, and they'll tell you to just give the right arm or the left arm, but there was no restriction on the domain, so that was it. That was the answer. All right, how are we doing on time? I think we should stop. We got about half the period left. Anything else very quickly? How about number 22? You didn't, the profit we never did, right? Did we do it yesterday? All right, I'm going to delete it anyway. Okay, I'm not going to worry about it. The only one that we did during our lesson was the discount and the coupon problem. Do you remember doing that? Yeah. That will be on the test. So I will give you a practice one today. Yes.
So is the profit going to be on the test?
No. So you can cross out the profit problem. Profit and revenue, we didn't do that. All right, little mozzarella sticks. Now what we're going to do is the new review. It is more honors questions. These questions will all be on the test. So if you need more practice, come 10. Watch the video tonight. This video will have these these problems done over. We did do these problems in our lessons, so you could always go back to your lessons and study. You got that?
Oh yeah.
Good. It's always fun. You want the answers to these too? I'm going to give you the printed out answers so you can do more studying.
No.
You happy? How you doing, Christopher? I know you got help tonight. I love that guy. I love that bald guy. All right, I can calm down now. I got to this review. I'm happy.
Is it right over there?
Oh yeah, it was a little chilly, just sneezing out, eye twitch a little bit.
See, I didn't expect you guys to have a lot of questions on the review, the first review, because it was Regents questions. I know you guys know how to do these. But these are the honors questions. So let's see if you remember doing these. I gave you 2 points, and I want you to find the equation of the circle. So the first thing I would do, if I were you, is I would do a little sketch of the 2 points. And because you're going to have to find the radius. You could also find the radius instead of drawing. How could you do it? Do you remember from geometry? How to
Calculate.
Triangle, right? And do it diagonal.
Pythagorean Theorem, or, good girl, distance. I hate the distance formula personally. I like to do the Pythagorean Theorem any chance I can get. But
I hate Ron.
you all know the equation of the circle, the general equation, x minus a squared plus y minus b squared equals r squared. You must know the general form of a circle to be able to do this problem. Because you're going to plug in the center and you're going to plug in the radius. I think they told me the center. That was good. So I got half the problem correct, as long as I plug it in correctly. X subtract negative 3. So that's going to give me a positive 3. Y subtract 4. So now the only problem is finding the radius. You could do it Rachel's way. She does the distance formula. Or you can do it Ryan's way. He says draw a picture and do the Pythagorean Theorem. I like his way. I'm lazy. I think this is easier. It's a 3-4. It's a 3-4 triangle, isn't it? So what's the radius? 5. So it's 5 squared, 25. All right, so that will be on the test tomorrow. There's going to be one of those whammy-jammies. Any questions? All right, now, this we spent time on. I'm not sure if you remember. We are now going to get, again, the center or the radius of a circle by getting it into the center radius form. But to get it into this form, we have to have perfect squares. And we don't have perfect squares in this equation. So we're going to have to complete the squares. Do you remember how to complete the squares? Let's go over it. The first thing you have to do is put the x's and the y's together. Because right now this equation is in standard form. So the first thing I'll do is I'll take the x squared and then I'll put the negative 4x next to it and I'll put a little box, a little square, because that's going to remind me to complete the square. And then I'll take my y squared and my little 2y, because they match, and I'll put a little square. And what do you think I should do with that 31, that negative 31? Yes, very good. Put it on the other side. Now remember, whatever you add to the left, you have to add to the right of the equation. We know that. Also, you got to know how to complete the square. There's like a little formula to complete the square. Do you remember it? Anyone? B divided by 2 squared. I should come up with a way to memorize that, like a little poem or something. I don't know. All right, so I take the big. You don't have to worry about the negative because it's going to be squared. So it's going to be 4 divided by 2, which is 2. And then you square 2, and you get 4. And then you take this b, which is the number 2. 2 divided by 2 is 1. 1 squared is 1. So altogether, I've added 5 numbers to the left. I have to add 5 numbers to the right. And I'm almost done. Now I just got a factor. And they are factorable, and they are perfect. Perfect square. What is that? Mammoth. It's mammable. X minus 2 and x minus 2. X minus 2 squared. And what about y squared plus 2y plus 1? Y plus 1 times y plus 1. And there, my little mozzarella sticks, is the center radius form. And the center is 2, negative 1. Remember, you always take the opposites. And the radius is 6. There are more examples in your notes if you want to practice more of those. And if you come 10th, I'll give you more practice ones if you want. All right, so that will be on the test tomorrow. There's a question that I'll also give you. Oh, I don't know. This is like a little puzzle. just a little question about, it's arithmetic, but I know you all know how to do f of 7, correct? And I know you all know how to do g of 2. And I want you to do that. And I want you to subtract. But then I want you to figure out what that would be equal to if the answer was put in g of a w.
Where is this?
What are you talking about?
You skipped question 4.
Oh, I skipped number 4.
Oh.
I'm sorry. Can we edit that out? No, I don't think we can. Oh, well. Sorry. I'm just so happy and anxious to finish them. All right, proof. We're going to do a proof. This is number 3, right? Crazy ladies on the right problem now. All right. Prove their inverses. Now, I don't know if I'll tell you this tomorrow. To prove an inverse, you have to prove the composition one way equals x, and the composition the other way equals x. Because what goes in must come out. When you have inverses, they undo each other. If you put a 3 in, a 3 has to come out. Put an x in, an x has to come out. That make sense? Okay, so do the composition one way. Let's do it this way first. So we're going to do f of g of x. We're going to do fog. What is g of x, guys?
X plus 1 over 4.
Very nice. X plus 1 over 4. Take x plus 1 over 4 and put it into f. What does f tell me to do? Well, it tells me to take 4, multiply 4 by what I'm putting in. This time I'm putting in x plus 1 over 4, and then take away 1 from it. Cross cancel the 4s. We get x plus 1 minus 1. Woo-hoo! It worked one way. Now do it the other way. Did I lose you?
Yeah.
Uh-oh. You understood the g of x,
Oh.
right?
Yeah.
Because I just look at g of x. I put an x into the g and I get x plus 1 over 4.
So
That's the answer.
okay.
Then I take this answer. This is what I'm doing. I'm taking this answer and I'm putting it in for that x. You take the answer to the g of x, which is that, and you put it into the f function. And the f function says, take the number 4, multiply it by whatever you're putting in the domain, and then subtract 1.
So you're always gonna start like from the right?
Yes, composition. You always start from the right, plug it into the function, get an answer, and then plug that into the next function. It's like one after the other. So do this one with me. Work it out with me. F of x is,
4x minus 1.
now take that and put it into g. So right there it goes.
Okay.
So it's 4x minus 1 plus 1 divided by 4. And what we're trying to show, it doesn't always work out to be an x, but we're trying to show if they're inverses, it'll work out to be an x.
Okay.
And it does, it works out to be an x. The negative 1 and the positive 1 cancel, and the 4's cancel, and then it works out to be an x. And we go woo-hoo, double woo-hoo. Because now I have proven that f and g are inverses. Okay. Come back if you want to do more practice with composition. Any questions? Don't be afraid to ask. He's going to do better on the test than some of you because you're not asking me questions and he is. Can we do number 4 now? All right. Sorry. Here we go. Number 4. How we doing on time, Booze? We're going to be, am I going to get through this?
Yeah.
All right, thank goodness. I want to do f of 7 minus g of 2. And I want to know, I'm going to tell you it equals g of w. You have to figure out the w. everyone can do f of 7. So you're just going to plug a 7 into the f function, and you're going to get 20. Right? 3 times 7 minus 1. Check my math. Now I'm going to do g of 2. I'm going to put 2 into the g function. The g function says x squared, so I'm just going to do 2 squared. And I get 4. And then it says subtract those two numbers. And I get 16. Now, 16 is equal to g of w. What is w? W is a number I plugged in, and I got 16. I know you know. Go ahead.
4.
Yes, of course. It's g of 4. Isn't it? Plug a 4 in, you get 16? I just thought that was a cute little question. I liked it. Good? Good? Everyone's good? Try number 5. Number 5 is called a piecewise function. We studied piecewise functions. Piecewise functions are just 3, like this one happens to have 3 little pieces. And what piece do you use? Well, it depends on what you're plugging in. If you're plugging in numbers that are less than 0, you're going to pick that piece. If you're plugging in the number 0, you're going to use this as your function. And if you're plugging in numbers greater than 0, you're going to use that piece as your function. So there's like 3 little functions in the function. So I know that I started you off pretty easy. I just wanted you to do some practice because I know this is going to be on the test. And really quickly, if you want to try these on your own, and then I'll go over them if you get them wrong. I gave you some composition here. One of you guys who wanted composition practice. I'm trying not to say your name to protect the innocent. Should I come around and help you? Let's see. How you doing? You're going to hang in there? You don't have to take it if you want, because I know you missed yesterday, but it's up to you. What you missed is indirect and direct. I got to give you the notes on them. If you want to come 10 or during lunch, I can catch up. Maybe the notes from someone else, but it's kind of easy. Well, it looks like everyone's getting the same answers. That's a good sign, unless you're all getting them wrong. Maybe you're right. You know me. I never trust my old brain anymore. We'll check it. You tried it with like just a price, right? You just put a price in and just say. Let's see some answers. Did you get A? 9? I saw a lot of people got those. C? -1? And then 26. Any questions? Now let's do the composition. Put a 0 in to the function. Well, if I'm plugging in a 0, the function I'm using is just the number 5. That's my answer. Now that 5 gets put into the function. And if I'm putting a 5 in, I'm going to be using, the domain is right here. So I'm going to use this function right here, plugging a 5 in, 2 times 5 minus 3. And the final answer is 7. Any questions? And the last one, I'm putting a -4 in. So I look, which one do I use? I look at the domains. These are the domains. if I'm plugging in a -4, goes into this domain. So I'm putting a -4 into this little piece, and I get 16. And then I take 16 and I plug it in again. And if I'm doing 16, I'm going to be using this function. So 2 times 16 minus 3 is, what is that? 29. Okay. Yes?
Can you do E again?
Yeah. Okay, so you ready? When you plug a 0 in, 0 isn't less than 0. 0 is equal to 0. So the answer, the y, is just going to be 5.
Okay.
So now I put a 5 in,
Oh, okay.
and I use, okay, good. I'm glad you're asking me. All right, we're on number 6. Can I move on? Everyone's good? All right, number 6, you have to find domain. I wanted to give you one more practice on these. From experience, I know that for some reason, students tend to have trouble with these domain questions. I know, oops, I'm starting to do them as I'm writing. I think I copied number. I think I'm copying. The first one's copied correctly? Is the second one,
That's 1 over.
oh, it should be a fraction like that?
The square root.
And there's a square root?
Yeah.
Oh, okay. Thank you. And then the C is just a fraction with an x squared plus 14x plus 40 on the bottom. Is that correct? Okay, we got to find the domain. This is a radical. Radical can only be, the number in here can only be greater than or equal to 0. Solve. Over here, part B, this can only be greater than 0. Can't be equal because it's in the denominator. So those are the two differences. A radical and then a radical in a fraction. And then you solve them. And I know you know how to solve them. And then this is 2x. When you don't have a radical, notice there's no radical, it's just a fraction. Well, the denominator, x squared plus 14x plus 40, cannot equal 0. If it equals 0, there's a problem. You have an undefined function. So you MAM, you T time, and you figure out what the x cannot be. The x cannot be -10 and -4. Greater than or equal to 0 if it's a radical. Just greater than 0 if it's a radical in a denominator. And if it's a denominator, you take the denominator and you say, well, the denominator can never be 0. Figure out what x is made of 0. And then x can't be that. Okay, last problem is a discount problem or a shopping problem. We practiced these in class. If you were here, check your notes. You're going to have a couple of parts to do. 20% discount. Write a discount function. Who's got it? 20% off.
0.80x.
Ooh, I love it. Because you're only paying 80%. You're plugging in the price, multiplying by 80%, and that's what you're paying. That's a great way of doing it, right? Easy. All right, we need a coupon function. I don't want to call your name, but coupon, it's just $10 off. So how would you write $10 off a price? You got it. Now they want you to write a function that does the discount first. So if the discount's being done first, you've got to write it this way, right? Discount first, take the discount, then the coupon. All right, discount first. Discount first is this. then take 0.80x and put it into the coupon, and you get 0.80x minus 10. Who had it? Yes, very good. Want me to do it again, slowly? Discount first. Put that answer into the coupon. Now let's do it the other way around. Coupon first. From right to left, coupon first. X minus 10. Put x minus 10 into the discount now. So it's 0.80 bracket x minus 10. Two different ways of calculating it. Which way would be cheaper? I did it wrong. Didn't I write on the answer sheet coupon first?
Yeah, the first one.
Is it right? Coupon first or discount
The
first?
first coupon's cheaper.
The first one is discount first.
Yeah, discount is cheaper.
This is cheaper.
Yes.
You plugged in a number,
Yeah.
plugged in a price. This one was cheaper for you.
Yes.
So I made a mistake because it was discount. First was cheaper. You sure?
Yes.
I plugged in 20.
You gave you 85,